Hello, I'm JW. This is part of a series on surge protection. This is part 3. This time we're going to have a look at the different types of surge protection available and where you might want to use those. And we're also going to take another device apart, and it's going to be this thing. This is actually a combined type of surge protector, so we'll have a look at this and see what's contained inside this one. So it's considerably larger than the type we've had a look at previously. So let's first of all have a look at the types of surge protection. And so we'll take that apart and see what's inside. Now there are 3 types of surge protection, and this is the one we saw previously in the other 2 episodes, and this is a type 2. This is the sort of thing you would fit in a typical consumer unit, and so we've seen this previously in the other episode. Now the other 2 types are unsurprisingly called type 1 and a type 3, and the main difference between these is the amount of energy that these things can absorb or actually deal with. So a type 1 can deal with the largest amount of energy. That's the sort of thing you would normally use if you had an installation, so that had overhead supplies, which might well be struck by lightning, or a building that already has lightning protection and things installed. Type 2, which is this thing here, this is the sort of thing you put in a installation that's had underground cabling, that type of thing, as obviously surge and things there may well be of a lower magnitude. And type 3 is the kind of item you would put at a particular piece of equipment, and that's again dealt with the lowest size or lowest amount of energy there. And don't be fooled in thinking you just use a type 1 for everything, because it covers everything below that, because that's not actually how these things work. Although a type 1 is very good at dealing with very large transients or surges, it's not so good at dealing with much smaller ones, which you might find, say, near a piece of equipment or within an installation. So as well as getting the 3 types, say type 1, 2 and 3, you can also buy equipment which has 2 types combined in one, so say type 1 and 2, and also all 3 combined in the same unit. So this is type 2, and we saw this previously with the 2 contacts inside, and basically it's a large metal oxide varistor on those ones. A type 3 might look something like this. Now this is a surge protected plug here, and essentially what's inside here is a single, much smaller metal oxide varistor. Now I'll take this apart. We have seen inside this before in a video quite some time ago, but I'll have another look inside anyway. So take the top off there, and this is basically just normal UK plug there with a socket on the back, and the surge protecting part on this one you can just see down side here. Just pry this out, and in this case it's just this very small blue item here, which is a metal oxide varistor, 2 contacts on either side there. So again, this will deal with fairly small transients or surges, but nevertheless it is obviously in there. And you can also get similar things like this built into extension leads, that kind of item. And you can also buy separate surge protectors of type 3, which would say fit into a piece of equipment, say like a fire alarm panel or something like that. This thing here, which we'll have a look at in more detail later, this is actually a type 1, 2 and 3 all combined into the same container, and you see this is a fairly sizable metal box. These are also considerably more expensive than the types we've seen previously, so we'll have a look at that say a bit later on. Now in terms of selecting these things, I've got this chart here. This actually comes from BG, or on their website there, but so I say it covers the information we want. So this is like some sort of flowchart here, and it's a question of which type you're going to use, so either type 1, 2 or 3. So at the top here we've got is lightning protection installed, combined with BSEN 62305. If it is, then you're going to need a type 1 SPD, and the reason for that is that if a building's got lightning protection, it's fairly likely that lightning strikes are going to be happening on or near that building, so you need the type 1 to deal with those very large transients that could occur from that. If not, then the question is there an overhead supply? And if there is an overhead supply, then again it's going to be the type 1. And again, this is because if you've got overhead supplies, cables on poles going down the garden or whatever, again that's fairly likely to be struck by lightning. So again, that's why you need the very high energy one there, the type 1. Now moving on, if not, so there isn't any lightning protection system and there isn't an overhead supply, so it's going to be an underground supply, then the question now is you need a risk assessment. Is there any imminent damage or danger to human life, public services or industry activity? So if the answer to that is yes, then you'll need a type 2 surge protection device. So what this is talking about really is that would the surge or transient cause damage to, say, equipment in the building? Would it cause problems with, say, an industry or factory or something like that? Is it going to cause problems for equipment that's required to keep people alive, for example, so certain medical equipment or whatever? And if the answer is yes, then you put your type 2 in. Further risk assessment, which we will look at in a later episode. Again, if it's positive for that one, you're going to have to put the type 2 in. And then finally down here, surge protection required as part of the AQ value or risk calculation. And again, we'll look at this in a later episode. So basically it's determining what the likelihood is of a surge occurring and also whether it's likely to damage things within the installation. So if any of those are yes, then you're going to be fitting the type 2 SPD, and that's the one like that, which we saw in a previous episode. And then additionally to that, so once you've established that you do need one, is there any sensitive electronic equipment within the installation? And if there is, then you may want to fit type 3. In this case, it's just showing one of these sort of extension lead type affairs, and that's similar to that plug thing we saw there. So you may wish to fit those for particular pieces of equipment. These type of things is one option, but so you can buy actual dedicated things to fit within, say, things like fire alarm panels or door entry systems or whatever else you might happen to have. So 3 types there. So type 1 at the top there, which is primarily for places where lightning strikes are going to be likely, or either direct on the wires outside or even direct to the building. Type 2, which is pretty much for any other installation where there's also going to be a risk to either people in the building, as in sort of medical equipment there, or equipment damage, and so on. And then additionally, the type 3 is used for individual pieces of equipment. But in terms of fitting type 3, you would always have a type 2 as well. You're not just going to fit a type 3 because, again, that's only going to do that individual piece of equipment. And unless you've only got one piece of equipment in the building, then you're going to put the type 2 in as well. Now, let's have a look at this here. This is actually a catalogue from this particular company which make surge protection devices. But we'll have a look at a few items in here. It's got this chart here in the front, which again is similar to what we saw previously. So again, the selection criteria are fairly similar here. So again, it's the first choice is whether you've got a lightning protection system or it's fed by overhead lines. If it is, or if it isn't, that will sort of guide you into the 2 sections there. In this particular case, to have a TT earthing system, and again, yes or no will determine the particular type you would get. And again, you've also got 3-phase and single phase as well, which goes down to the particular products in question. Now I've got a diagram here which basically shows you if the lightning strike would actually hit the building, and this assumes the building's already got a lightning protection system installed, that the kind of currents you're talking about here, in this case 200 kA or 200,000 amps, and how that's distributed throughout the building. So of that striking the building, 50% of that is going to go into the electrical installation, so in this case about 100 kA, which obviously half of that goes to ground, the other half ends up within the electrical installation. And at the bottom here, so this shows the building fitted with external lightning protection, the maximum lightning strike of 200 kA, and then you've got the actual time involved here, which again is measured in microseconds. This will dissipate through the external lightning conductor system. 50% will go to earth via the earth rods. The remaining 50% will enter the building directly on the main incoming panel, as the external lightning protection system is bonded to the main incoming earth bar, and we can see that in the diagram here. And this is why you need your surge protection there. And the maximum rating of combined lightning and surge arrestor is 100 kA, so it's assuming that the 50% split is there and the lightning strike is not going to be more than 200 kA there. There's another important point here. So if the building has stub distribution boards more than 10 metres away from the incoming panel, these boards will require additional protection. And usually type 2 surge arrestor here is sufficient, and also fitting outside final circuits when a combined type 1, 2 and 3 will need to be fitted. So if you've got final circuits say more than 10 metres away, or equipment more than 10 metres away, it may be necessary to fit additional protection there. In a lot of domestic properties in particular, that's not over likely. Let's say if you've got things going outside or in greater than 10 metres, you may need additional surge protection further down those cables. Now I've got some examples here of the types that are available. So these are combined types, so types 1, 2 and 3 all within the same units here. And the important point here, we can see that the actual total current that these will deal with, as it says there, total lightning current is 100 kA, which you saw previously. And if we look on the next page, so here we have the type 2, this has to be a 3-phase item, and again we look in the table here, so again you see the currents here is 20 and 40, and it withstands up to 50. So clearly if you put this on one that there was a lightning strike of say that 200k and half of it goes into the installation at 100k, these things simply aren't going to do the job, they're going to be destroyed. So considerably lower actual current there. And if we look on the page for those of a type 3, so here's an example of a type 3. Again, principle is very similar, but again, if we look at the actual current here, you can see it's 3K and 5Ka, so again, considerably lower, but again, only designed to deal with impulses of a much lower energy. And as I said before, it's not just a case of bunging in the one with the highest rating, because although that can deal with, say, up to 100 Ka, it may not be as good at dealing with ones of much smaller magnitude, so you do need either the correct type, or in some cases all three installing to provide complete protection. And then this small one here, this is an example of one you could fit directly to a piece of equipment, or as it's got here for, say, a socket or fire alarm panel. Little small device there, just has the three connecting wires which you connect inside the piece of equipment. And as in a previous video mentioned, it's not just the mains cabling coming in, you can also get surges coming in on other types of cabling. So here we've got surge arresters for telephone, fax or modem, and again this is the type of thing you would fit on a say a telephone connection there. And on this page here we've got an example of 104 power over Ethernet, just basically a plug-in device there, just goes in line with the cabling. And then here we've got one for CCTV equipment, and again it's just a straight through connection there, so on both ends with the appropriate connector. And of course you can get these in a whole variety of styles depending on the exact application that you're using them for. And the final thing in here, we've just got this one here, which is again it's a type 2, so similar to what thing we've seen before, but this is actually for photovoltaic or basically solar panel systems. As I say, it's surge protection devices for protection of the DC side before the inverter, because bearing in mind solar panels of course are going to be on the roof outside, have a load of cabling that comes into the building, so again fairly likely to get transients on those. So these ones are designed to work specifically with DC, and of course to cover things like solar installation. So it's pretty much any cabling that comes into the building from outside which could bring in surges or transient overvoltages. And if you've got an area that's susceptible to those, then you do need to consider all of the stuff coming in, not just the mains wiring. So now let's have a look at this thing. Now this is a combined type 1, 2 and 3, and this also happens to be a 3-phase one as well, so you've got your 3 lines here, the neutral and the earth connection as well, so 5 connections required on that one. This comes in a rather substantial metal case. Now this one that we are going to take apart, this particular one is actually broken, which is primarily why we have it here, as these things are surprisingly expensive to buy. Now this particular one is a combined type 1, 2 and 3 tested protector to the relevant standard for use on mains power distribution systems, primarily to protect connected electronic equipment from transient overvoltages on the main supply, such as computers, communications or control equipment. So pretty much what we've been saying in the previous videos there. Now this particular one is used at boundaries up to lightning protection zone 0. We may have a look at those in a later episode. Typically at main distribution board location, with mortar metallic surface entering through to lightning protection zone 3 to protect sensitive electronic equipment. And as we saw in the previous episode, sensitive electronic equipment these days means pretty much every piece of equipment, because virtually everything now has sensitive electronics inside. Although this is a 3-phase device, the connection is pretty much the same. It's just a question of connecting the 3 phases, neutral and the protective conductor, to the terminals there. And they do obviously do a single phase model as well, and of course several other types as well. So let's have a look at this one. This is an ESP415M1, and this one has indicators on the front which are actually LEDs which light up, and it's basically green for full protection. Green and red means something's broken, but it's still doing something. And if they're red, then it's completely busted and needs to be replaced, as the case with this one. And if the thing here flashes, then there's some other fault between the actual supply itself, so that would require attention. And 3-phase 480 volts RMS maximum, and so it connects to all 3 of the phases, neutral and earth, at the bottom. Now this one has an additional terminal block on the top here. This is nothing to do with the surge protection. What this is here, it says here, is a volt-free contact, common, normally open and normally closed. And what this is for is so you can connect this to some additional equipment, because it's all about having the indicators on the front here, but of course that requires someone to actually go and have a look at it at regular intervals, which, let's face it, in the real world may not happen. So what you can connect here So in its simplest form would be, say, a buzzer, so that if something goes wrong, the contact closes and the buzzer sounds, and you can also connect this to various other things like building management systems and so on, basically to alert people that, yes, this thing is actually broken, so attention is required. And so having someone go around to the particular device and check on the colour of the indicators, not necessarily the best solution. Now, I've already had a pry at this, but we'll see if we can just dig in. Of course, these are not really designed to be open, they're supposed to be completely replaced when they have failed, which this one, of course, has been. So let's see if we can dig in and see what we've got inside. Now, in terms of the contents of these, this should have all three varieties inside. So the type 1 and 2 and 3 as well. Plus, of course, we've got that remote monitoring part with the little contact there, rather than just the indicators on the front window. Now here's the actual metal case. This is just the lid, basically. Just got the holes, or the sort of transparent bits there for the LEDs to show through. Earth wire here, which goes over to the connection point here. Just remove that. I've also got this tape on both sides of the case. Now presumably that's going to be there to stop things on the main assembly here from arcing across to the metal case, and we can see here there's a certain amount of either soot, dust or similar actually coming off of there on both sides, more so on the other side than the first one, so not a whole lot to see in that one. This is the main unit, and we can see the LED indicators here, so there's a 3 for the 3 phases, and then the additional one here which indicates if there's a problem with the actual supply, mainly I think because if there's a voltage between neutral and earth, which obviously normally should be in the sort of 0 range, but that will illuminate if there's a problem with that. One thing notable on the board here is got these resistors here, and you can see around them the actual circuit board is considerably discoloured, as it's almost sort of brown there, and the same with these 3 here and this one, so these have been getting pretty hot during the lifetime of this device. Whether that's by design or that's because of some fault isn't particularly clear. This is the remote contact here, and this will be the relay which switches between the 2 states there. So it's basically one pair is closed by default, and then if a problem occurs then it switches to the other pair there. And so you can connect that to some other system to alert people that a problem has occurred. Not a whole lot on here other than various passive components there, so a few transistors, just the LEDs, and these rather overheated examples of some resistors, and then the ribbon there goes down to the board underneath. On the front here we've got these pins coming across at right angles, and we can see that these come across to these fuses on this other board. So we've got 2 fuses there, 2 in the middle, and there's also 2 over this side as well. Now this is going to be the destructive teardown because most of this on the front here is actually soldered in, so I've just cut those connections there, just unplug this thin ribbon here, screws on the top here, so this remains the top board here. Nothing on the back there, and we can see again the darkening of the circuit board material where those rather hot resistors have been. So this top piece looks to be just the basically the control there to output to your building management system. And of course you've got the LED indicators and so on, so not a huge amount of stuff there, and certainly no surge protection on this top board there. Got some plastic pieces here which go through, so we'll take those out. This device, by the way, new, is about £800, so that's why we're destroying a busted one and not just buying one to take apart. So interesting screws there, these appear to be nylon, so no doubt chosen for their insulating properties that go through this plastic sheet on the top here. So this lifts away, and all we've got on here is the sort of ribbon type flex connector there to the top board, and then it just goes onto these tracks which just go across the top of these, and then we've actually got holes and slots cut into this which just sits over what's below. So this is presumably being used as some kind of sense piece, so that if something here melts or burns, it's going to cause one or more of these tracks here to fail. As I said, there's no actual components or anything else on here. You see from this side you've got the white tracks going across there, so presumably if these melt or set on fire it will burn through one or more of those, and that will be detected by this top board and therefore show a fault indication. So quite an interesting design there, and the fact that this is just plastic is purely from the fact that this is all part of the same actual piece there. So yeah, it's just been stuck down on the top there, so we can actually peel that away from the material below. So yes, that's certainly interesting construction. So now we're actually getting down into the surge protection part. So again, if we remove these spaces and things there, and again those should unscrew. Now remove some of the other fixings here. A little bit of damage occurred there, and this whole bottom piece here lifts off. So on this layer we've got whole stacks of these, which presumably are the surge preventing elements, probably the metal oxide varistors there. And on the back of there we can see the various circuit board traces go through to the various elements, and we have these little plastic, or what appear to be plastic spacers, which just fit over the top of each individual element. And we can see on there, on the edge here, that they are actually soldered on both sides. So this will be one contact on this side and then the other, and then there's a whole stack of those rather than just a single one, which you saw in that sort of surge protecting plug affair. And this of course has this whole array of these things going all the way across. So there's a substantial amount of stuff in these. And then also interesting on these, you've got these plastic little spacer things on the back here, and these press down onto these metal spring contacts underneath here. And these, again, there's one of these for one of those. Again, these just press onto the metal casing on the back here, or at least they do at one end, and then the other end goes onto this insulating sheet here. So they're only connected at the one end there, and it's just a piece here, presumably just to hold them in position so that they will stay lined up. So it's one of those, and then one of those just fits into the slot there and just goes underneath there with a certain amount of spring pressure there. And we've also got these elements here in the middle, and the little, what looks like to be ceramic cards there with the individual components attached on there as well. So there's an awful lot of stuff in these things. Now I've actually broken a couple here, and you can see it's just one side and the other, and then it's got the presumably the oxide material in the centre there, and they all go back down, say via those traces on the back here. It's very heavily coated with the green mask on this one, but as you can see they're all individually soldered, so it all goes all the way across in actually a large stack, and then they all go back down to the bottom here to the large terminals on this side. And those terminals actually go onto this separate board here. That's the one we cut away on the top piece before, and it's also one with those fuses on the front there. So there's a normal clip on the top here, and then the bottom is actually a cup which is actually soldered down to the board here. Now we can see there 25 amp fuses, 440 volts, and these are the ceramic ones actually made by Seba, so they will have the sand filling inside. And again, those will come through on the back here, and you just go down to your main terminals, which is this block here. Earth comes across to that point on the side there, so it goes both into the circuit board, and then the other one came off to goes to the front metal case. And we see that comes through on the back here as well. Here's a close look at one of the fuses. Actually broke the end of this, so they're very tight in the bottom. You can't actually get them out particularly easily or at all. But you can see it's the ceramic material, and it did have the sand filling inside. And we can see there's actually 3 individual fuse elements inside, so rather than just a single fat wire there, it's got 3 separate wires there. So yeah, made by Seba, 25 amps there, and there's 6 of these, so 2 for each of the phases presumably. So 2 there, 2 there, and 2 there. So they press into that clip there and then go into that sort of cup thing soldered down onto the board. Now there's not a whole lot else on this particular thing here. You've got the terminal blocks here which come across, so that's the 3 phases, neutral and the earth connection, and all of those come across to the board there, as well as the earth going over to that additional connection there. 6 fuses there, and then the only other thing inside, there's some what appear to be resistors down here, some in there, and then there's also 2 on the end and 2 over this side, and essentially those ones come through onto the back here, and we can see the circuit traces, and those come up to these pins here which we cut. They went over to that top circuit board, so presumably that's being used as some kind of sense or detection thing to determine whether the, first of all, the thing's actually powered on and what the state of the various inputs and so on is. So no doubt finding some kind of detection or fault monitoring there as well. And then we can see the much larger traces coming across to the various other parts on the back there. So again, it's just coming right through from the incoming connectors there. And again down at the bottom there where it all links through to the bottom board, and that's basically soldered through with these large links on the sides here. And again over this side as well. And there's a bit difficult to see. We have also got down in there additional of those connectors going through. So it's basically these very large metal pieces go through. And that's what we're seeing on the back here. So there's 2 here, 1 in the middle, 1 there, and again 1 over that side. And then we've got these other large pads here, obviously 6 of those. And that's actually those fuse holders there. 2 there for each of the 3 phases. And this bottom plate, it is just spring contacts there, which those little plastic pieces just rest into, and they're all in contact with the actual metal case here. So at this end they just rest on there, and of course we press down when those top board is in position. And I think this yellow material here is just being used for location to basically secure the other end of it so that they also stay in the correct position, lining up with what's above, because they're all essentially columned onto this metal back plate here, so no other electrical components there. And that's the complete assembly there from the bottom. So yeah, it's just a piece of circuit board material there, no actual components or connections on it, just purely used to mechanically support these things in the correct position. What that looks like on the bottom is there's the bottom of those things with the little plastic pieces, which are just loosely fitted in there with 2 locating pegs and the piece that goes over the bottom, and then those just literally sit over the top of that. And just locates on like that, and then as the pressure is applied from above, the spring pieces there press onto the metal casing on the back. Now I've got here a piece of one of those, which presumably is the metal oxide varistor component. Now this actually broke off when I was trying to unscrew the other parts there, but I've got a piece of it, so let's just see what the resistance of this is. Now in its default state, we just use the normal ohms reading. We should get pretty much infinite resistance between the 2 sides, as these things are obviously not designed to conduct at normal operating voltage. So if we just check between the 2 sides, and yeah, there's no connection there whatsoever, so that's pretty much as you would expect. The edge is no, the edge isn't conductive either, it's just the different material there. Yeah, this side is conductive within itself. The black material apparently is not, so this white is a conductive pad, and essentially there's going to be one on both sides. So that's what's obviously for the solder connection. So you get pretty much 0 ohms there, but between one side and the other, yeah, we're getting nothing at all. Again, that's just a few volts from a battery. Now let's try with this thing, the high voltage tester. This does up to 1000 volts. Now, I've got these clips here, so what I've put is just a piece of plastic, one of the spaces from the thing, over one side, and then that will be insulated, and we can just clamp onto the other side with the other jaw there. So just place that like that. So essentially the red one is connected to this side, but the black one is insulated, and then this side it's the reverse. So the red one is insulated from the disc and the black one makes contact. So if we place that there, and if we turn the handle, we should see that as we go at a faster speed, the resistance should fall away to very low levels, and at slow speed it should stay somewhere over there. So let's move that out of the way there so we don't get shocked by it, and we shall turn the handle, see what we get. So okay, so at lower speeds there, it's certainly in the sort of 50 plus megohms range. As we increase speeds, yeah, you see it's dropping down, that's in the sort of 5 range. And if we go with a moderately fast speed there, see it's gone down now to the sort of 2.5. And again, going faster there, see it's dropped right down into the sub 1 megohm range. And again, if we slow down, it's going up sort of 5 megohms, and so on. So pretty similar to what we saw previously, though the voltage that this converts over at is probably going to be lower, because bearing in mind in the actual device, it's not just a single one, it's a whole stack of these for each of the particular parts, and they're all basically soldered across like that. Just a quick final look at the circuit board here. So there's no sort of microcontrollers or any kind of fancy intelligence in this thing. It's all based on non-passive components. So this piece in the middle here, where the traces went down to that previous board, that's just a question of closed or open circuit. So closed in normal operation, and if one of these becomes open, that would indicate a fault. One of the things was basically blown up and melted through. And then the other connections were the ones on the front here, which went to that board on the front there, which have those resistors there. And again, presumably just to monitor the various voltages on the input. And again, illuminate one or more of the LEDs here in the event of something failing. So these resistors here have certainly got extremely warm there. Whether that's by design or by fault isn't particularly clear. And in terms of the components on here, essentially it's just a row of diodes, things along the bottom, a couple of resistors there, bridge rectifier here, so I'm supplying a DC supply for the LEDs, a few capacitors there, transistors here, which presumably going to be used to switch on and off the various LEDs in the various colours, as these so can be green or red, as we saw on the outside of the product. And then at the top here, just a relay. Once again, we're just switching the contacts here between the normally closed and the normally open in the event of some fault occurring. And in the back of that, again, just the circuit traces there. So look, there are 3 types of surge protection, so 1, 2 and 3, and the likely places you may want to use them. Or in the case of this thing, it's got all 3 combined in the same unit, so you've got a very large array of elements inside there, and obviously had the smaller ones which you saw across in the middle as well. So quite a lot of stuff in that one, but then considering the price of it, that's not entirely surprising. I'd say this is not the kind of thing you're normally going to fit in your average house, because obviously it's designed for more industrial or commercial locations, but the principle is the same. It's a high voltage, very short duration pulse coming along, and you need something to absorb that energy, in the case of these discs on this board here. And that absorbs the energy rather than it going into the installation and destroying things. Although these are quite expensive, far cheaper to have to replace this every few years than to replace, say, tens of thousands of pounds worth of electronic equipment within your factory or whatever. So that's it for this episode. There will be more episodes on surge protection in the future. Until then, thanks for watching.